Great, hence let's look at paper 2 that we've just done today, 17th of November 2025, and let's look at possible answers, suggested answers. Anyway, instructions are there, they are given, and please go through them. Here we are, it's question number 1. It talks of Mr. and Mrs. Lamini bought a house in one of the suburbs of Pretoria. The diagram below shows part of the house's plan. This is a diagram that we have there. We shall use it. Anyway, what are the questions? Question 1. Identify the type of map indicated above. They've already told you it's a plan. So what kind of plan? This is a floor plan. This, we call it a floor plan. We shall say it's a floor plan. Okay, 2 marks. How many doors are visible on the plan? How many doors are visible on the plan? Let's see. We have 1, then there's 2, 4, 5, 6, 7, 8, 9, 10. So 10. Then if you count this as 2s, that means 10. Then this other one will be 11. And one of them will be what? 12. Because these are double doors. But then what about these ones that you left out? No. 8, 9, 10, 11. Which other door are we leaving out? We're looking for a door. These are 1, 2. Yeah, the answer could be 10. The answer could be 10. 10 to 12. 10 to 12 doors. Okay. Explain the numerical scale. Let's go and see. The numerical scale is this one here that we see. What is it? So the numerical scale, we shall say 1 unit. 1 unit on paper equals to 100 units in real life. It equals to 100 units in real life. Determine the probability of locating a window on the northern side of the house. Northern side of the house, we go. It's this other part here, north up here. So from this side up to there. Is there any window? No. So we shall say 0. Someone else would have said impossible. But the moment you say impossible, it's about the likelihood. How likely? But 0 is a perfect answer. Okay, we go to question number 1.2. In 1.2, we have an annexure there. All right, 1.2, we're looking at that. And the question is, determine the year in which Mrs. Lamini was born. The question is, determine the year. So, but then before we do that, let's look at this and say, Mr. Lamini is planning a birthday party for Mrs. Lamini. It will be her 43rd birthday on the 19th November 2025. Below is a recipe of a cake that will be baked and different measuring tools to use when measuring the ingredients. Okay, so question number 1. Now the person is planning to make 43. This is 2025. So what we shall say? 2025 minus 43. And the answer became 1982. That's the answer. That's how we get the year when the person was born. Okay? You get your age minus the current year. Sorry, it's the current year minus the age. You get the year when you are born. Identify the measuring tool that can be used for the following. Write only the letter. Take note of that. Write only the letter. So under this question, we shall only need it. So 3 cups of flour. 3 cups of flour, what will they be? 3 cups of flour. Among these ones, we have A, B, C, and D. Which one? 3 cups of flour. I believe this would work. So here the answer becomes what? A. Margarine for the RISP. Margarine for the RISP, let's see, go. Under the RISP we have, they're telling us 3 tablespoons of margarine. So if they're 3 tablespoons, nothing, we shall use this. This is it. We shall use B. So our answer here becomes what? B. The circumference of the cake. Now, when you look at it, we are left with this and this one here. Which one is more flexible? It's this one. Because the circumference, we have to take it flexible. So the answer there becomes what? D. 2 marks each. If Mr. Lamini wants to bake 2 cakes, how much milk will he use in meals? Let's go and we check on the recipe there. The recipe says how much milk do we need? 2 cakes. So 1 cake takes 1 cup of milk, and yet 1 cup of milk is equivalent to 250. What about if there are 2 cakes? That means they need 2 cups. So meaning 250, yes, times 2. And the answer will become 500 mils, which is actually what? This is approximately half what? Half liter. That marks the end of question number 1. Let's look at question number 2. Question number 2. Question number 2, this is what we're going to use. It says, Mrs. Morris decided that she wanted to replace the real grass in her garden courtyard with artificial grass. The layout plan of her garden, as seen below, shows the area she wants to replace with artificial grass. Can get together? So here it comes. The dimensions of the circular area to be replaced with artificial grass. So it's circular area, so it means it takes a circle. Okay, that's fine. Let's look at this. They're asking us, define diameter in this context. Please, you can say diameter is twice the radius. Twice the radius what? Of the artificial grass or of the circular garden. That's fine. Determine the radius of the grass as indicated above. Now, take note, radius will always be half the diameter. So they have given us the diameter as 3 meters. We shall divide by 2. Answer becomes 1,5. Don't forget the units. Please, this is measurements. So 1,5. Someone is going to ask, where did you get the 3 from? The 3 is here. This is the diameter. Why? It's from one end of the circle to the other end of the circle through the center. So this one becomes the diameter. But we are interested in the radius. So we shall say radius half the diameter, which becomes 3 divided by 2, which is 1, okay. So we continue. Calculate the area that Mrs. Morris wants to cover with artificial grass. Round your answer to 2 decimal places. Now, as you know very well, the area to be covered is a circle. That means we shall use pi r what? Squared. Let's substitute 3,142. That's the pi times what we've just got, 1,2 squared. Together. Then this will give us the answer as, please, 3,142 times 1,5 squared. Press the answer there. Make it decimals. So it's 7,07. They told us to round off to 2 decimal places. Don't forget the units. Meters what? Squared. If Mrs. Morris Gardens is 5 meters by 7 meters, calculate the surface of the garden that will not be covered by the artificial grass. In other words, this is length, and this is breadth. But some part won't be covered. Guess what happens? We shall say, first get the area, which is L times B, and we say 7 times what? 5. The answer became 35 meters squared. Of this 35 meters squared, an area, the one that we've just got here, it won't be covered. It will be covered by the grass. That means this 35 minus the area that will be covered. So the answer becomes, don't mind about this because they are both meters squared. Leave them alone. Concentrate on the numbers. So come back here. Remember, we've left it here. So you can easily do this. You can easily do this. Get the 35 minus, put this in brackets. So you get your answers 27,93. 27,93. Don't forget the units, meters what? Squared. Okay, we continue. Question number 2.2. 2.2. 2.2 says, Mrs. Maris wants to put a fountain in the middle of the lawn. The fountain has a rectangular bowl with the following dimensions as indicated below. The diagram represents the dimensions of the rectangular. It's this one here. Okay, 1 by 1,5. Okay. Then they are telling us, or they're asking us, calculate the area that the rectangular bowl will take up if Mrs. Maris installs it on the lawn. So they have given us a formula here, which is L times width, which is L times width. And remember, our L is 1,5 times the width, which is 1. So the area will become 1,5 meters what? Square. That's the area of the rectangular bowl. Okay. They are asking us 2.2.2. Calculate the total area of the artificial grass needed if Mrs. Maris placed the rectangular bowl with the fountain in the middle of the circular grassed area, assuming that there will be no grass under the rectangular bowl. So what you're going to do, get the area of the circle that we got up there minus the area of this rectangle that we've just got. Remember, we got the area of the circle 7,7 minus, now we've just got 1,5. Okay, let's come here and say the area, it was this one here. Or you can even come here and say minus 1,5. So the answer becomes 5,57 meters what? Squared. So that will be the answer. That will be the answer. Now they're asking us, calculate how much Mrs. Maris will pay for the artificial grass if the grass costs this much per meter squared. Now, we shall say 5,5 that much times, then why am I using it? Because this is what is going to be remaining to be covered. So times 699. And when you multiply that nicely, it's going to be 3,893 rands and 43 cents. That is it. Together. That is it. You can use a calculator at this moment in time. The area that you've got there times 5 times 699. 699 rands. And the answer, you get it as that. 3,900, comma. Oh, it's because you never wanted off that much, but it's fine. You can get your answer, other answers. Other answers as we go on. That marks the end of question number 2. Let's look at question number 3. Question number 3. We have a map there, and we shall study it nicely. I believe it fits. Okay, let's go to the questions. Okay, the scenario. Mrs. Lamini wants to travel from Kempton Park to Wits Rugby Stadium. Below is a map she will use. Okay, shall identify the map. Identify the type of map indicated above. 1. Since it has routes only, you can call it a route map. It has a route of what someone will follow. So we shall call it a route map. She stays in Kempton Park. She has to travel. It's only showing routes, okay? This is Braamfontein. It's not Bloemfontein, Braamfontein. So it's not a provincial map. Anyway, Mrs. Lamini states that if she takes the R25 instead of the M90 to get to M1, towards the Wits Rugby Stadium, it will be 2 kilometers closer than the M90. Show with calculations how Mrs. Lamini made her conclusion. Simple calculations. Let's come here. We're talking of M90, this blue, you see? But then if you follow the M, it says it's what? What's the distance? 28,9. Yet, when she uses R25, which is here, it covers a distance of what? 26. So what's the difference? That's what we want to know. So it's going to be 28,9 minus 26,9. And indeed, it's 2 kilometers. So remember, they told you, made her conclusion. Show with calculations how Lamini made her conclusion. Yeah, this is how she made her conclusion. So we are not verifying anything. Yeah? But she's right. Yeah? Okay. Mrs. Lamini leaves her house at 8:30 a.m. She stops at the engine petrol garage for 5 minutes. Take note of that. This is time. 5 minutes to buy coffee. Then drives on. Calculate what time Mrs. Lamini will arrive at Wits Stadium if she takes M90 and M1 from Kempton Park to Wits University. Show all calculations. Now, we are aiming at looking at the time. Calculate what time. This is what we are looking at. What time will she arrive? Meaning, so she's using M90 together. That becomes what? M1. So M90 then turns into M1. What are we looking at? She's going to spend 31 minutes. So it's the 31 minutes plus the 5 minutes. So how many minutes are they? 36. Plus the time when she left her house, which is what? So she's saying that. What did she say? Arrive at calculate what time Mrs. Lamini will arrive. So we are going to add these two. So I'm here looking at it, just see. This is 9. Because 30 plus, where can I write it? Okay, let's say 8:30 plus 36. So these are 30 minutes. 30 minutes plus 30 minutes, you get to a full hour. So this means it's a what? A 9. But this was 36, so I'm leaving you with 6 what? Minutes. If you don't know how to do it, just get your answer here. Say 8:30 plus 0 hours, 36 what? Minutes. And it becomes 9 hours, 6 minutes, which we have here. Okay. Mrs. Lamini picks up her nephew at Wits Rugby Stadium and then decides she will come home on the M88 through Santon because she has heard that the Springboks will play a rugby match in Johannesburg on Saturday. Name the stadium they will see on their way. We are using M88 now. Together? M8. That's the first thing that you have to look for. Where is M88? Now, when you look at M88, it's this one here. You see that? But when you follow it nicely, you see that it's a blue one. It comes like this. You see that this is certain where we are, and then it comes down. Here we don't have a lot of things, but we have Emirates. This is airline, but then we have Emirates Park. So the answer there is supposed to be, the answer is supposed to be what? Emirates Park. The stadium seen there, it's what? Emirates. Emirates Park. And we get our 2 marks. We continue to question number 3.2. Below are the dimensions. Are you seeing that? Below are the dimensions of a rugby field. They take note of that. Then this is 100 meters by 70 meters. Then when you come here, they specify playing field is 100 meters. Total length of the field is 120 meters. Then width of the field is 70 meters. But now they're asking us 3.2.1. Tiana believes that if a forward runs 60% of the length 5 times in the field of play, then he does an average length of 300 meters. Show with calculations how Tiana calculated 300. Now, what I want you to know, first and foremost, Tiana believes that 60% of the length 5 times. This is where the calculation is. That's where the calculation is. So what are we going to do? We shall say, first and foremost, we shall look for 6% of the length. Which length? Of the field of play. Field of play will be play field. It's 100. So length. So we shall look for 60% of 100, which gives you what? 60 meters. Then if there are 6 meters, how many times? 5 times. So calculate with 5. The answer becomes what? 300 what? Meters. Show. They didn't say verify, they said show with calculations. Okay. Tiana stated that Chris Colby best time over a distance of 100 meters is 10.79 seconds, which gives Christina an average of 9.35 meters per second. Verify showing all, but we are verifying the speed in meters seconds. So the distance covered is 100 divided by 10.7, showing. So there we go in and we say, we shall pick our calculator here. 100 divided by 9, divided by 10, not 9, divided by 10.79. And the answer becomes what? The answer becomes 927 meters per second, which is here. So is it right or not? It becomes what? Incorrect. It's not valid. It's incorrect. Okay. Because the answer has changed. Look, he claims 9.35. Then we have 9.27. So it does not work out. Okay. 323. During December, Johannesburg receives a regular rainfall. South African Rugby Union is of the opinion that it damages the field if rugby is played during December. If the cost for the special turf for a rugby field is 310 rands per meter squared with installation, the organization calculates calculates that it will cost a total of 2,170,000 to replace the turf for only the playing field. Verify showing all calculations. Now remember, for only playing field. Now we come here and we remember very well that the playing field is how long? 100 meters. How short? 70. So we shall need first get the area to be covered, which is going to be, area to be covered is going to be L times B, which is 100 times the 70. You get 7,000. Of the 7,000 meters squared times 310. Indeed, you end up having 2,100,000. They said verify showing, okay, then you don't, the moment you hear the word verify, your final answer has to be what? Because now we've got the same answer as this. So the claim is what? The claim is correct. Okay. Question number 4. Question number 4, we are looking at question number 4. Question number 4, you shall be looking at the map of Soweto. Anyway, below is an extract from a map of Soweto. Study the map and answer the questions. What are the questions? Question number 4.1.1. Describe the route you will follow if you want to travel from Johannesburg CBD to Carltonville. Include roads and general direction to describe your route. Now, it's 4 marks. The moment you get something like this, check where you're moving from. You're moving from this side. So, you will turn your map and let the map face that, because now, what you're going to do is that when you look at it nicely, all right? When you look at it nicely, it's Johannesburg CBD. So you're moving like this, you reach there, then you reach and you come this side like this. This is what you're going to describe together. So now what we need to know, what are the roads? By the way, as you move, what road are you using? Now from CBD Johannesburg, you're using N1. So you say N1. You are moving. Now as you move down here, this is your right, and this is your left. You move here, you reach the conjunction of these, you understand? What do we say? Slight right. So you turn what? Right. Then you follow, you continue. Turn right onto, this is N3. N3. As you go to N3, find a turn, the first turn, then turn right again. What are you turning onto? You are turning on N12. Follow N12, pass the roads and and you reach Carltonville. So this is what I wanted to hear. Mention the road you're using, which turns are you taking, and if you take the turn, on which road are you going to? If that's what we need. That's how we get the marks. Please, you turn there and next turn and you follow. Always from where are you coming from? Okay, so now here we shall say, use, you can say use. Can I write here? 4.1. Use N1 towards what? Towards the south. Then at the conjunction, turn right. Turn right into N3. Turn right into N3. Here, turn right into N3. You see, this is N3. This is N12. We don't need N12. So you continue. Continue with N3 until the second conjunction. At the second conjunction again, turn right into N12. and you say continue with N12 till the Carltonville. Those are please don't overwrite the sentence. Don't overwrite the scenario. We need it in point 4. Talk of the turns. Where are you turning? Where are you heading? That's what we need. All right. 4.1.2. 4.1.2. 4.1.2 says use the bus scale as a unit. Write the bus scale as a unit scale in form of 1:2. So now the bus scale that we have here, it's this one here. Take note of that. It says 2 centimeters are equivalent to 1,000 meters. Guess what? They want it to be 1:2. Then what you're going to do, you say, okay, they've told you 2 centimeters. Here I'm answering question number 1.2. 2 centimeters are equivalent to 1,000 meters. For you, you need them to be both in the same unit. So what do? The meters become centimeters multiplied by 100. You end up having 100,000. So this is 2 now. 2 centimeters are equivalent to 100,000 centimeters. We need this to become 1. What do? Divide by 2. Divide by 2. So this will be 1:2. When you look at it critically, becomes what? 50,000. Becomes 50,000 because this 2 will die with this. You remain with 50,000. So the unit is 1:50,000. Okay. So Mrs. Lamini is of opinion that the distance from Heraldo Park to Protea City as the crown flows is 4 kilometers. Verify her statement indicating with calculations. Now, let me do question number 4.1.2. 4.1.3, sorry. So what are we going to do? We are verifying this. This is actual distance. So as you are grade 10, you're going to measure. First and foremost, you look for these distances. Look for the distances that we have. The distance between Heraldo Park and Protea City. So you're going to measure. You put your ruler here. This is Heraldo Park. Put your ruler here up to here. Protea City here. All right, understand? Here I got something to do with 8,5. These were centimeters. For you would have got 8,3. Others will have got 8 centimeters themselves. Doesn't matter. We are using different, but it should be 8 and something. Eh? So now if you used 8, that would be better. That means 8 centimeters. What would they be in real life? But remember, you've already got the scale as 1:50,000. If not, ask yourself, in the scale they are telling you 2 centimeters are equivalent to 1,000 meters. What about the 8? So what do? We cross multiply this 8 times 1,000 equals to the 2 unknown. The 2 multiplies, you understand? The 2 multiplies that, the 8 multiplies that. So in this case, this is 8,000. 8,000 equals to 2. What do? Divide by 2. Divide by 2. This goes with that. So the distance is, but these are meters. Meters, the person wants what? Kilometers. What happens? You divide by 1,000 to make them kilometers. Wow. So we have 4 kilometers. And they are saying, verify the statement including the calculation whether is correct. You can say it's correct. Now, don't get scared. If you measure and it's more than 8, as I told you, 8,5, 8, whatever, and you don't get the same, yes, we shall mark according to your suggestion because of your calculations. Anyway, in December 2024, the total number of tourists visiting Soweto was 1,5 million. This was an increase of 6.75% from December 2023. Mrs. Lamini calculates, rounded to the nearest 100,000 people, that it was about 1,400,000 people who visited Soweto in December 2023. Verify her statement by showing all calculations. Remember, there is this increase. So meaning there's a number that increases 100 plus over 100. I believe you get something to do with this. Leave it like that. So meaning there's a certain number that increased by that much, and they got the answer as 1.5 million. They're asking us to verify the statement. What are we doing? So it's 6 from December. So we need to calculate and get it. We need to know how much was it before saying to the nearest, and she claims that this was this much. So what are we going to do? We shall need to divide through by 1,0, 1,0. I've not included the 6 zeros. I'm looking for the number. So whatever number I get, it will be in millions. So what do? I pick my calculator there. I'll take 1,5 divided by 1,0675 equals. So the answer equals to that. You see that? 1,405 0515 by 222 15224. But these are what? Millions. What do? Let's change it to million. Just multiply by 10 to the power 6 times 10 to the power of 6, because a million is that. So it's 1,405,152. 1,400,000. Comma 22. So we don't need comma. They said 100 to the nearest 100. So nearest 100 stops here, and these ones become all zero. So it's 1,400,000. Meaning that is what? Her claim is what? Valid. And this brings us to the end of questions 4 and the end of our proposed answers.